So good afternoon class. So today we are going to discuss an important point in the field of mathematics, that is differentiation. So earlier we had seen the various concepts related to the differentiation, and we will start from the basic. We will start from the crux of the matter and we will go up to the height. So first of all we will see what is basically differentiation. And we had studied the two concepts, that is properly, that is you can say it is more popular, that is differentiation as well as integration. The differentiation means to differentiate or to disintegrate, or to integration means to sum up, summation of all the basic entities, summation of all the small entities to a bigger entity, that is basically integration, that is summation of, that is sum up. So in this case, so today we are going to deal with an important topic, that is basically differentiation, and in this very first class we are going to derive a very important formula, that is basically the first principal derivative that is basically the first principal derivative. And as we have already seen, any function is there, they are basically the broad classification is two type of functions, that is continuous function and discontinuous function. The continuous function is a function in which for every value of x there will be a corresponding value of y also. Suppose if we are writing here y is equal to fx, if we are writing here y is equal to fx, f of x, that means y depends on the x. As x increases, y will also increase, or x will decrease and y will also decrease. So y is a function of x. In other words, we can say y is a function of x. For every value of x, there will be a separate value of y. And if it is a continuous function, we are able to draw the graph. Without lifting our pen. That is, we can draw the graph smoothly without lifting our pen. That is basically the continuous graph. So in this case, y is equal to fx. It is a continuous graph, and we are plotting it between the two axes. It is x-axis and the y-axis. In the x-axis, we are having here the x-axis we are having the x coordinates, and in the y-axis we are having the y coordinates. So we had drawn a graph, that is basically y is equal to fx, and it is a continuous graph. We had drawn this graph very smoothly without lifting a pen, without lifting the tip of the pen, and it is not breaking anywhere. It is smooth, it is continuous. So we had entitled that particular type of graph as y is equal to fx, that is continuous in nature. Secondly, we had plotted this graph between the two coordinates, that is the x coordinate and the y coordinate. This is the point, the A point is there, the x coordinate is x, and when you are moving x direction towards the right side, then the coordinates of x becomes x plus h, because we had increased the distance, and this distance is increased by h. So we had plotted here x plus h, and it is the x coordinate. So in this particular graph, that is continuous graph, we had entitled 2 points. We had kept the 2 points basically named as A and B, and if that graph is there, we had basically entitled this particular graph as A and B. And A and B, these 2 points are basically the important points on the graph through which we will discuss the tangent and the secant of the circle. So it is basically the two coordinates will be there, fx and fx plus h. So in this case, we are going to differentiate about the various parts of there. It is y is equal to fx and y is equal to fx plus h. So for this value, for x, at this point, the coordinate of A is x and y. For every coordinates, we are writing here that A coordinate is x and f of x, and B coordinate is x plus h and fx plus h. We had already studied how we are determining the coordinates of a particular point in a geometry, in the coordinate geometry. So based on that, we are writing here the coordinate of A will be x and fx, and the coordinate of B will be x plus h and fx plus h. So based on the earlier slope formula, slope is equal to y2 minus y1 by x2 minus x1. This is the slope, this is the formula of the slope. So y2 minus y1, in this case y2 minus y1, we will just write fx plus h minus fx by x2 minus x1, that is x plus h minus of x. So in this case we are just deducting it. It will be f x plus h minus f of x by h. So this is the slope of this particular secant. This particular secant is there. This is the slope. This is the secant. That is, this is the particular secant, as we know in the circle. In the circle, if we have drawn a point, this is a particular circle. If two points are there, this is chord A and B, and if it passes through the circle, then it becomes secant. It is the secant. So that is the particular slope of the secant. That is, slope of the secant is equal to f of x plus h minus fx by h. So in this case, if we are seeing here carefully, this particular portion, this portion is there. If we are decreasing the distance, if we are decreasing this particular distance, this secant it is going closer to the tangent. So a point will come, a time will come, if this particular h becomes 0, the distance, this two distance between A and B becomes 0, this secant and the slope of the secant becomes the slope of the tangent. That is, slope of the secant slope of the tangent. That is slope of the tangent. That is what we have to derive. Any derivative, the derivative of a function is the slope of the tangent. So we can write here, we are decreasing the distance. So we are putting here limit, we are applying the limit. So limit h tends to 0, f dash x, that is basically dy by dx, is equal to f x plus h minus fx by h. So this is a very important formula in the field of derivation, in the field of derivative. We had applied here limit. Limit means we are not knowing the point at which the h becomes 0, but it is certain that at certain point h will become 0. So we had applied here limit h tends to 0, f dash x is equal to dy by dx is equal to f x plus h minus fx by h. This is very important formula, and this is entitled as the first principle derivative. So using this formula we can calculate dy ds of sin x is equal to cos x, and dy ds of cos x is equal to minus of sin x. So this is basically today's class. We had derived the very first important formula, that is the first principal derivative, and going ahead we will discuss some of the important parts related to it, some of the important derivatives related to it, and we will solve the various concepts. We will solve the various numerical problems using this concept. So this is for today, and going ahead we will try to solve all the numerical problems associated with the same concept. Till then, thank you. Good night.